of magnets that are invented. So magnets are invented with few kinds of materials, and magnets which we will use will be artificial magnets. Natural magnets are found in rivers or some hills, landmines. So let us just see about types of magnets. So let us start with the U-shaped magnet. Here let us draw. Here it is too broad. Perfect. Done. So this is a U-shaped magnet. I will name it at the top now. Sorry, at the bottom. U-shaped magnet. U-shaped magnet. So now let us color it with our two side poles. This side we will have North Pole and this side we will have South Pole. Perfect. Okay. Now let us color it. So let us represent North Pole with red. And write north here. N. Now for south, blue, dark blue, which is indigo. Which is represented by S. So this is north side and this is south side. Now for the next magnet will be horseshoe magnet. Same like U-shaped magnet, but again starting bent from like this. I'll draw and show you. Here until here done. There I show. Not like this, not transparent, just a little.
Please like, subscribe guys. Different types of magnets shapes. U-shaped magnet already done. Now
Horseshoe magnet.
horseshoe magnet.
Shall I increase a little broader?
Allow U-shaped magnet. It will be so nice.
I love bar magnets. Little front. Now let us again split it into half. This side we will write north and this side we will write south. So the magnet's name is horseshoe magnet. Magnet.
Need ఇటు సైడ్ పెట్టేసుకో.
Horseshoe magnet. This is horseshoe magnet. Now time for bit coloring. So let us take red and indigo.
First draw it all. And then you can color it, Nana.
Okay. I will use scale. Scale it. Scale it. To divide them. This is horseshoe magnet. Next, bar magnet. Bar magnet is easy to do using lines only. Cut in the middle. This is north. I'll write with color afterwards. I'll write in the south. North, south. Done. And the magnet's name is bar magnet. Bar magnet. Magnet. Bar magnet. Next, let us draw cylinder magnet. Like bar magnet, but some of it in cylindrical shape.
అన్ని ఇదివా ఓకే కదా
నేను
మళ్ళీ పోతాం పోతుకుంటే
ఏం రోజు బస్సు కూర్చో
ఓకే
Done. Here will be north, here will be south. This is how a cylindrical magnet looks. After while every magnets at the last of this slide we will color using shades which will make the magnet more attractive, and wait for it until the end please. So the magnet's name is cylinder magnet. Cylinder magnet. Done. Now let us draw needle magnet next. Needle magnet. I will write the name here. Needle magnet is also easier to draw. You can even know how to draw, how magnets work. Every video will be uploaded what you want, and if you want any kind of videos we will explain if you will keep in the comments. Please subscribe. Two lines here, dot from like this. Okay. Here I'll rub some little mistakes. I'll keep it little front. Done. They meet it. Now let us keep the line. This is north and this is south. Now let us color the magnets. Red for north and indigo for blue. So starting with the horseshoe magnet, this side will be the north. See, north. North is represented by red. North. Now south. North and south. Now for the bar magnet. North at the top. North, south at the bottom. S for south. Done. Now I will show the cylindrical magnet. This is needle magnet. South, north. Done. Now the whole video isn't done. We will have more magnets. We will have more magnetic types. Those magnetic types I will draw on this side.
ఇంకా ఉన్నాయా? అవునా?
Now is the time to use a real magnet. The circular magnet. We need a circle after all to draw circular magnet. And I have a circular magnet, so I am drawing it. Done. Circle formed. This is circular magnet. The color is this. See, the color is this. It seems okay. Circular magnet. Circular magnet. Again we need the circle to draw another magnet. The ring magnet. Okay. For the ring magnet, we will have a small hole in the center. So this is how a ring magnet looks. For now I don't have a ring magnet because it's broken. I throw it away. But same like a circular magnet, it has a hole in the middle, like I have shown in the diagram, called the ring magnet. Now let us draw the oval shaped magnets. This I have. This is an oval shaped magnet. Can you see? This is an oval shaped magnet. Oval. Which will be in an oval shape. Now time to use shading to make it look in 3D. I mean not perfect 3D, just a light shade. Okay. Oval magnet. Next, let us introduce the rod magnet, similar to cylindrical magnet. But in rod shape and is longer than cylindrical magnet. Or I will draw a straight line with the scale.
మాలే తింటారా కొంచెం
Rod magnet. Completion.
అయిపోయినాయా
Almost. More to go, Buji. Rod magnet.
నేనన్నా వద్దాను మూడు
So, till now we have shown U-shaped magnet, horseshoe magnet, bar magnet, cylinder magnet, needle magnet, circular magnet, ring magnet, oval magnet, rod magnet. Now let us draw cylinder magnet.
Cylinder.
Circular magnet. I know what you want to say. Already we have drawn one circular magnet, then how another? You can ask. A bigger circular magnet, like a tin, it will be. Now I'll draw lines between them to differentiate. Mom, does this look in 3D?
Yes. Very nice, Nana. You drawn very well.
Thank you, Your Honor. Over.
Last one, na.
Circular magnet. Last one. Spherical magnet. Mom, I said magnets will be there in artificial magnets and natural magnets now. Do you know how natural magnets are created?
Don't know. North Pole, South Pole. With
Magnets are created using minerals. It's created using copper, uranium, iron, and a few more minerals. Adding those in a specific mold, which has a shapes in it. Like U-shaped magnet has a specific mold. Horseshoe magnet has a specific mold. Bar magnets have cylindrical magnets, needle magnets, circular ring, oval, rod, circular magnet, and now I will draw spherical magnet. Like that. They will have separate molds. This is what I told about spherical magnets. Okay. Now I should turn this circle into a sphere like thing. This portion I'll leave. be a magnet. This side road. See, perfect size. Is it nice, Buji?
Nice, Nana.
Spherical magnet. Spherical magnet. If I am calling magnet, I am remembering the name of Magnus Carlsen. Just a second. Total in an hour
It's
I
a
was
turn
checking.
చేయను.
Huh?
It's a turn చేసి చెప్పేసి అవి.
Just a second. Somewhere I kept my black pen. It's missing.
We'll check later. We'll close this and we'll check.
No, I have to draw the borders. That's the reason.
It's okay. Show Nana.
Or I'll sharpen draw. I'll sharpen the pencil.
Enough, Nana.
Okay. In school, I will draw the borders, the dark. First, the U-shaped magnet. So these are the all types of magnets. First starts with the U-shaped magnet. North means N, represented with the color red. S means south, represented with the color blue. So this side is north and this side is south. So horseshoe magnet. Next, horseshoe magnet is similar to U-shaped magnet, but is always curved and just a little bent. Just a little bent in shape. Next, bar magnet. The top will be north and the bottom will be south. Next, cylinder magnet. This is same like bar magnet except in cylinder shape. Top will be the north and so bottom will be the south. Next, needle magnet. These needle magnets are used in compasses. In old time, when compasses were invented, they used this needle to find north, east, west and south directions. So that's the needle magnet, which you will see in compasses. But nowadays, due to our technology improvements, we have our compass in our own mobile phone. But still, tourists will carry compasses. Okay. Now let us start with the black magnets. Circular magnet, which looks like this. Live example. See, this is a 2D circular magnet, and I have a question. Where can we find north and south for these? Where can we find north and south for this? North and south are located on the disk's face. This may be north or south, they did not written. This may be north or south, they did not written. But we can do experiment. If the like poles attract, they repel, right? Where it went? Hello? I think it fall down.
Okay, leave Nana.
We can take it afterwards. Until that time, I have another magnet for experiment. Time to remove the magnet. And magnets should not be just a second. And magnets should not be like this, or they will be weakened. How do you know? If a magnet and a magnet attaches like this and you keep it, by tomorrow it will be weakened a little in its magnetism. So you should not keep it like this. You should keep a paper in between the magnets, like how I did.
Why?
Here a magnet is there, here another magnet is there. To know why, I will upload a video tomorrow make about magnets. Okay, physics playlist will be there. In that we will upload. Okay, so these are magnets. See, they attracted. Means these both are same poles and these both are same poles. But what if we do with different poles? The magnet literally moves. Escaped. It flipped and attached. Same happens with every magnet. If you want, I can show with the oval magnets and cylindrical magnets. But already I lost one of the circular magnets, so I don't want to lose another one. So sorry, I am not showing. Next comes the ring magnet. Same like the circular magnet, but has a hole in the middle. I was having one ring magnet. It was broken into half. While I was playing, it fell down and it broke. Because magnets are made up of soft iron, not hard iron. Or if we will catch only, it will fall down. That's why magnets are made up of soft iron. And these attract to magnet. Because these are called magnetic materials which attract to magnet. So now I have that half which is sticked to the fridge. Next comes the oval magnet which I showed you here. These are the oval magnets. Next comes the spherical magnets. I showed you. Rod magnet I don't have. And circular magnets you can form by using these magnets we have no. These magnets. These if you will stack up one by one, you can get the shape of this magnet. Okay. So this is it about today's video. Thank you for watching. And however, these are made up of some metallic material, so they are attracting to magnets. Thank you for watching. Please subscribe. If you want to know more about magnets, you can check out the physics playlist which will be there in our YouTube channel, where I will explain why magnets should not be attached like this.